Okay, so here's some extra problems and problems we went through in class for section 10.4, inscribed angles. Now, the theorems for inscribed angles is that the inscribed angle is half of the arc that it intercepts. So this angle is an inscribed angle because its vertex is on the circle, and this angle is half the measure of the arc that it creates when it goes to the sides of it. So, excuse me, if this is 81 degrees, here's this intercepted arc. The intercepted arc is double that, so it's 162. On number 12, you've been given the arc, but now you're looking for the angle, so divide that by 2, 46 degrees. And then number 13, this is a good problem because they're asking for angle P, which is an inscribed angle, but you don't know the arc of NQ. However, you know this is 120 and 100, so that's 220 total. That leaves 140 degrees for NQ to make up 360, meaning angle P has to be 70 degrees. Okay. All right, next. We are solving for R and S. Okay. Now, in order to solve for R and S, well, actually, R is easy. Angle R is formed by SRT, and it has intercepted arc ST. Okay. Angle Q is formed by SQT and has the same intercepted arc. So if these two angles have the same intercepted arc, that means they have to have the same measure, which is 32 degrees. So angle R is 32 degrees. Okay. Now it works the opposite way for solving for angle S. Angle S and angle T have the same intercepted arc of RQ because it's RSQ and RTQ. So these two angles of 5x plus 4 and 6x minus 2 have to be equal. So subtract 5x, add 2, you get 6 equals x. So when you plug 6 in for x, you get 34 degrees. And that's 18. Okay, next example is number 25. Okay. Now 25 and 26, you have to recognize that you have a diameter and the triangle is inscribed inside there. If that's the case, the measure of this arc okay, is 180 degrees because that's the diameter. If this is 180, the inscribed angle is half of that, so it's 90, which means we have a right triangle. So 3x and 5x minus 2, or sorry, minus 12, have to equal the 90 that's left over after you take away the right angle. So you get 8x minus 12 equals 90. Add 12, 8x equals 102. Divide by 8. That ends up becoming out, I don't know, 51 over 4. It's going to be like 15.25 or something. So let's do here 102 divided by 8. 12.75. I was way off. Okay. So that's x, 12.75. And then another measure of angle C, well, that's just 5 times 12.75 minus 12. So I will do that real quick. 5 times 12.75 minus 12. So 51.75. Okay. All right, last couple examples then are from problems 29 and 30. Now, these problems come out to play in the sense that we're looking for angles H and angle G. We have an inscribed quadrilateral here. So if I look at, let's say, the arc that's going to form angle H, it's going to be GKJ. That forms angle H. Its opposite angle, K, is formed by JHG. So right there you can see the two arcs make up the whole circle, which is 360 degrees. Well, these two inscribed angles have to add together to make up those arcs, meaning that these two guys have to add up to be half of the arcs. So 2x plus 21 is 180. And that's the theorem we had, is that opposite angles of an inscribed quadrilateral are supplementary. So 2x plus x is 3x. Subtract 21. We get 159. Divide by 3. X is 53. So plug 53 back in. 2 times 53 is 106. Okay. And then we do the exact same thing for angle G. 3y plus 9 and 4y minus 11 are the opposite angles, so they have to be supplementary. 7y minus 2 is 180. 7y equals 182. Y then equals 26. Yeah. So plug 26 back in. 104 minus 11 is 95. There we go. Sorry, I was kind of, I realized just ran out of space on here. So I added these two together, set them equal to 180. Got 7y minus 2 is 180, added 2, divided by 7, 26. Plug 26 back in for y here, and you get 95 degrees. Okay.